Hi everybody. Today we're going to be focusing on polynomials and graphing polynomials. We're going to go ahead and talk about a few key elements of graphing, and then we'll actually get into the graphing aspect in the second video. So to start off, I want to review some concepts about polynomials that are really important in this chapter. The first is that in order for something to be a polynomial, it cannot have fractions, variables, or negatives in the exponent. So that's something that if you didn't write it down in the last section, make sure you write it down now. Also, if I ever ask you what the degree of a polynomial is, that's going to be whatever the highest exponent is. It may not necessarily be the first, but you always want to look for the highest exponent. And then lastly, the leading coefficient is just the number that's in front of the variable with the highest degree. So for example, if you are given a polynomial 2x to the 7th plus 4x to the 4th plus 3. So this would be a polynomial. The degree would be 7. Okay, so there's a degree. And the leading coefficient would be 2. All right, so that's all you really need to know is those basic parts. And then those two things, the degree and the leading coefficient, are going to be helpful when we start graphing. So the first thing I want to do is just have a little image here for you of the types of polynomials. These are the main ones that we're going to be focused on. The first three on the top row should be familiar to you. So we've got a constant function or a degree. That's just going to be a horizontal or vertical line. Okay, and then a linear function would be something like y equals 2x plus 3. So the constant function might look like this, y equals 5. So there's no variables, it's just something equals a number. Then we've got our linear functions, so those are just lines. And then this is what we learned in the last chapter about quadratics, where it's a parabola. So that would be something where the degree is 2, like y equals negative x squared plus 2x minus 7. All right, so those are our main ones we've learned about. And now we're going to start getting into higher degrees, where we have a cubic function that's going to be a degree of 3. A quartic function has a degree of 4. And then a quintic has a degree of 5. And what you should notice is the higher the degree, the more potential turns or curves that we have in our graph. So here the degree was 1, so the max number of curves we could have is 1. The degree here was 3, so we could have 2 turns. The degree here was 4, and we could have 3. And the degree was 5, and we could have 4. Now, it doesn't have to have that many, but that's the most it could have. So this is important to keep in mind. The degree, if you take 1 minus the degree, that's going to tell you the potential number of curves. All right, so make sure you have examples of those written down, or at least the names. And now let's talk about end behavior. End behavior is going to be really helpful when we graph, because that's going to tell you what happens to the graph as you go all the way to infinity or negative infinity on the x-axis. So it's going to help you get the shape of your graph. That's important. It's also going to be dependent on your degree and your leading coefficient. So I've got a table below here, and we're going to fill that in. And you're going to notice there are 4 different categories we can have for end behavior. So the first thing that we want to look at is when the degree is odd. Okay, so maybe that would be like a degree of 3 or 1 or 5 or 7 or 27, and the leading coefficient is positive. What this means is that the end behavior of our graph is going to go different directions. So if it's positive and odd, our graph might look something like this. On the left side, it's pointing downward, and then on the right side, it points up. So now what happens in the middle, this is not what will always look like. I just drew a random example. But the key here is that it points up on the right and down on the left. All right? So then what do you think would happen if the degree was odd and our leading coefficient was negative? Well, the opposite. So the left side will be pointing up, and the right side will be pointing down. Okay, so this part's up here and then down here. And like I said, what happens in the middle, that will just depend on the equation that you're given, what the degree is, how many turns you could have, and so forth. So really all we care about is the ending parts here. If the degrees are even, we have a positive and a negative leading coefficient. We have 2 different cases. If it's even and positive for the leading coefficient, then both ends are going to be opening up. So maybe it looks something like that. So notice that both ends of the graph go upward forever. If the degree is even and the leading coefficient is negative, then both will go down. So that might look something like that. Okay, so those 4 end behaviors you're going to be using to help you graph your polynomial functions, and then I'll show you some tricks that we can use to figure out what goes in between. All right, so make sure you write this graph down or this grid. That's going to be really helpful to refer to. So these are our last examples in this first video. All we're going to do for each of these is talk about what kind of end behavior they have, and then determine if we could tell if it's an odd or even degree. And then by looking at the graph, we want to figure out how many real zeros or solutions or roots, all the same thing, that we have. So let's look at the first example here. Notice in this problem that both of our sides of this graph, so over here and over here, the graph is going up forever. So what we could do is we could write this as x approaches positive infinity, okay, the y, or f of x, approaches infinity also. So what this means is as I go to the right, my graph goes up. Okay. So that looks good. Okay. And then I could do the same thing as x approaches negative infinity. So as I go to the left side of my graph, so I'm going left, following it, what tends to happen? My graph goes up. So I'd say my y value, remember f of x just means y, goes to infinity also. So that's all it means by describing the end behavior. And this is just some notation that's easier to use. You could physically write out a sentence if you wanted, but this is much shorter. So as x approaches the positive infinities, the y goes also up to infinity. As x approaches negative infinity, the y goes to positive infinity. Okay? We could do the same thing. In this one, we could tell if it's an odd or an even degree. So if we know that both ends are pointing the same direction, that automatically means it's going to be an even degree. Now, we don't necessarily know what the degree is, but we know it has to be an even number. All right? And then lastly, when it says state the number of real solutions, all you have to do is look at how many times it hits the x-axis. Those are always going to be where our real zeros or roots are. So in this case, it hits the x-axis 4 times. So we have 4 real solutions. And then we're done. So let's try this one real quick, and then I want you guys to try the last one. So this one, if you notice, the end behaviors are going different directions, so here and here. So now we're going to have a little bit of a different answer for part 1. So in part 1, we could say as x approaches infinity, what happens to the y? Well, let's look. So as I go to the right on my graph, so I'm following it towards the right, what happens? My graph goes down, so my y is going to go to negative infinity forever. And then what happens is I go to the left side of my graph. So as the x's go to negative infinity, so as I go towards the left side of my graph, as I follow it, what happens? Well, it's going to start pointing up. So my f of x, my y, will go to positive infinity. Okay? Then we could go ahead and look at the degree. If it's going different directions, that means the degree is an odd degree. Okay? So that could be a 1, it could be a 25, it could be 3, anything like that. Okay, and then lastly, the solutions, it only hits the graph on the x-axis once, so we have 1 real solution. Oops. All right, so hopefully you're catching on to those. The biggest thing is being able to tell which direction it goes, positive or negative infinity on each side. Go ahead and try this last example here and see how you do. If you want me to check it in class, I'll gladly do that. But that's it for this first video. Thanks for listening.